Yeah, Professor.
Thank you very much for organizers and chairman.
Yeah, thank you.
My topic is review of lithium-ion battery recycling for automobiles. So this article is published in the International Journal of Minerals, Metallurgy, and Materials. This was accepted last week. You can see these topics. And this is a year versus new passenger car production. Nowadays, most of cars are using the gasoline. But in the future, after 30 years, electric vehicle, hybrid vehicle, plug-in hybrid vehicles number increase. Therefore, the total using lithium-ion battery vehicle is more than 0.1 billion in 2050. This figure shows the shipping amount, million US$ and year. The most valuable materials is a cathode material here. And then next is separator, anode, electrolyte. In the 2022, approximately 15 billion US$ were produced. This table shows the year when was developed and estimated market share of various cathode materials. The first is LCO, lithium cobalt oxide, was developed 20 years ago. And then LMCO, NMC, LFP, LMO, LTO, NCA. There are many kinds of cathode materials were developed, especially LCO, NMC, and CA has a large specific energy and then using cobalt. But nowadays, LFP and LTO, no cobalt utilization, and the safety is very good, and the lifespan is very large for LPO and LTO. The most utilization in 2018 is LCO is the largest, 37%. Next is the NMC, 29%, and then LMO is utilizing 21%. But in the future, it will change. This table shows the future demand for resources, rare metals, nickel, cobalt, manganese, lithium. And the demand is comparing the after 10 years and nowadays. Especially the lithium demand increases 8 times after 10 years. Lithium is also expensive, $16,500 per ton. And next is a cobalt. Cobalt, after 10 years, 6 times demand increases. This is the most expensive, $80,000 per ton. The recent decrease of cobalt utilization in cathode material reduces the supply risk for cobalt from mining. However, the benefit by recycling shrinks. This is a lithium-ion battery recycling reuse publication year and number of reverse recycling paper. We published 10 years ago, and then after that, so many papers recycled and reuse of reverse increased. This is data comes from Web of Science. More than 1,100 papers were published, but other journals included more than 3,000 reverse recycling paper was published. Especially the vehicle, automobile recycling paper showed here about 200, it's 20%. Most of paper was published in Chinese researchers. This shows 3 types of reverse packs, module, and cells of electric vehicle. The pack voltage is usually 350 to 375 voltage, and the weight is about 0.5 ton to the 200 kilogram. This pack is made of the 16 to 48 module is compact used, and then making a pack. Also, this module is composed from the lot of cells. In the cylindrical, for example, 444, and hard case 12, pouch type 4, this type. The size is about 7 centimeter to 30 centimeter. This voltage is a 3.6 to 3.8 voltage, and then mixture, the total voltage is 350. This is a chemical composition of different kinds of leaves. LCO here, LFP, LMO, NMC. So LCO here, NMC utilizing the cobalt. But all kinds of lithium-ion battery utilize the lithium. But lithium molecular weight is low, so therefore the 1% to 2% lithium is utilized in the lithium-ion battery. This table shows the commercial recycling companies for leaves. So it's a treatment in 2018, but the largest treated company is here. Chinese company, Green Eco Manufacture High-Tech Corporation, and the European company, Armet. They processed 20,000 ton leaves in 2018. The companies adapt three kinds of technological method. Pyrometallurgy, this company, Smith Mosoni in Japan. Hydrometallurgy, Dowa, Nippon, here. And Umicore utilizes the pyrometallurgy plus hydrometallurgical method for the recycling. This is today's topics, flow sheet. Flow sheet of leaves treatment process for 3 hours. First, we have to get materials from the mine or oil deposit. Mineral and oil resources come from mining. And then rare earth is important, we have to reduce it. And then next, leaves design for automobiles oriented for reuse, reuse, recycle. And then material produced. And then leaves production by using parts. So I show the cell module package. So inside there is a cathode, anode, separator, electrolyte, etc. And then this leaves is utilized in the citizen. And then after utilization in everybody, the long life by upgrade and maintenance with monitoring is important. After that, and leaves can be reused somewhere in the return here, an improvement. The remainder goes to waste spent leaves. This goes to the recycling area, material recycling. There are many kinds of techniques. First, discharge to prevent a fire, sorting and crushing, binder removal. And then each materials come here. One method is pyrometallurgy. In the heating, alloy is produced, and then alloy can be reused. And slag, there is a lot of lithium and hydropyro method, metal recycle. And then other sorting, physical separation treatment. And then cathode, anode, shell, separator, electrolyte are separated. So cathode was going to reuse or reuse again. And this goes to the hydrometallurgy process and the metal recycle. And then anode reuse possibility. And the outer shell going to the metal recycle. And then remainder go to the landfill. We have to reduce the landfill. Next explanation, we show this number order and then explain. First, reduce. The reduce means the decrease of variable rare metal utilization and the reduction of spent leaves amount by remanufacturing process of used parts, including 3R model and small size leaves production. Second, design. The inverse manufacturing design of leaves for easy assembling and dismantling is necessary to reuse parts and recycle the materials. The cooperation of the design group and the recycling engineers are necessary to cooperate, establish the extended producer responsibility, EPR. Reuse case. The reuse of EVs is inevitable for both batteries produced manufacturers and vehicle production companies using batteries. The EVs reuse as an energy storage system in the smart grid, and the repeated EVs charge system have to be considered. For the recycling area, discharge of used EVs for recycling treatment. In the pyrometallurgical process, the high temperature incineration can automatically discharge leaves. The leaves discharge is also performed by soaking leaves in the salt aqueous solution before pyrolysis. The economical rapid discharge technology in leaves has to be developed. Crushing. To separate each material in leaves, various kinds of crushing machines are used. The crushing is performed in the inert atmosphere, CO2 atmosphere, and liquid nitrogen atmosphere. The prevention of fire and the emission of toxic gas like HF is necessary for the crushing process. This table shows the various binder removal methods many scientists researched. One is the thermal treatment, air atmosphere here, nitrogen atmosphere, vacuum atmosphere, and microwave roasting sometimes used, and also solvent utilization in the wet method, NMP, DMF, DMSO, and sometimes in the fruit juice can be dissolved the binders. And then other method is a mechanochemical method, high voltage pulse. The combination of thermal and solvent utilization might be necessary for economical binder removal from cathode and anode materials from the aluminum foil or copper foil. And next, see the pyrometallurgy. The pyrometallurgy process feeding leaves into the furnace does not emit the toxic gas due to the exhaust gas treatment. The pyrometallurgy process produced alloy from cathode materials and the slag. In the metal alloy and slag production by pyrometallurgy, the leaves collection containing the same quality of metals is necessary as the feed material in the furnace, because recently there are many kinds of lithium-ion batteries. The use of pyrometallurgical method. And the reuse, we always use the heating. The regeneration methods are classified into the solid-state reaction, the hydrothermal process, the Zorgel method, co-precipitation, and carbon thermal reduction method. Each method has advantages and disadvantages. By the thermal treatment, the regeneration of cathode and anode particles are important in the viewpoint of the economical treatment, because not only cobalt recycling is not good. Recycle of slag and dust after pyrometallurgical treatment. The chlorination roasting to recover lithium inside the slag or the pyrometallurgical treatment of spent leaves is studied. However, the technology to reduce the lithium recovery cost is needed by considering the high energy consumption by the thermal treatment of slag. This table shows the physical separation methods of liberated particles. There are many kinds of physical separation. The simple is sieving, separation of size, pneumatic separation by using the wind, flotation using the surfactant, magnetic separation, wet or dry, eddy current separation, electrostatic separation in the atmosphere. The various kinds of mineral processing techniques can be applied with a combination of thermal pretreatment. Next is the reuse of cathode powder. The separated cathode powder after the physical separation can be reused by chemical treatment. Various kinds of cathode powders are regenerated as cathode powders and also anode nanowire. The regeneration and reuse have to be considered. Metal recovery from the cathode by hydrometallurgical process. There are many kinds of reagents that can dissolve the cathode powder. The leaching reagent of cathode particles is listed in the next table. After the leaching, the extraction, precipitation method, and so on are utilized to recover. The separation methods of leached metal ions are listed in the next table. So this is a leaching reagent of cathode particles. Inorganic, it is classified as acid, many kinds of acid. Many scientists studied. Alkaline, also ammonium sulfate, ammonia, sodium sulfate. And organic, many things, ascorbic, citric, succate, malic, aspartic. But this organic solvent, when we use, we have to use a hydrogen peroxide. And also, this kind of liquid is also possible. The other method is biological. Acidity of bacillus peroxidans and acidity of bacillus peroxidans, etc., with sulfuric acid, and this can be leached of the cathode particles. After leaching, how can we selectively collect the metal? There are many kinds of chemical methods. Solvent extraction. There are many types of reagent. Cyanex, D3HPA, PC88, RIX, Cyanex, many things. And chemical precipitation. Just a hydroxide, but a sulfide and phosphate, this one, phytic acid, many things. Selectivity is possible. Also, electrochemical deposition is possible, and sorting out method. Membranes sometimes uses to get the cation. Biosorption also can be utilized. Anode graphite reuse. Anode graphite particles can be reused as anode after the separation and particle treatment. The spent lithium-ion battery anode to graphene and graphene oxide is proposed. Aluminum and copper recycle. The aluminum frame and the aluminum and copper foils, cathode and anode, can be separated by eddy current separator and recovered as material recycling. Polymer recovery of separator. The separators are not active components in LIBS. However, they play key roles in LIBS safety to keep the mechanical strength, thermal stability, wettability, and 20 to 25 nanometer ports. Polymer reuse and recycling have to be studied as important subjects for the future. Nowadays, not yet. And next, the recycle of electrolyte. Now, the distillation is a useful recycling method of electrolyte. In the future, if the solid electrolyte is used, the new reuse and the recycle method have to be considered. So, summary. The rapid growth in the publication number for LIBS recycling is important for the future electric vehicle utilization. Many kinds of recycling ideas have been accumulated. The composition improvement of cathode material will continue in the future. Therefore, various optimum recycling systems have to be prepared. Also, design considering reuse and recycling is necessary for the manufacturing of LIBS. On the other hand, the reduction of valuable cobalt utilization in LIBS reduces the benefit of recycling. Therefore, the reuse and regeneration of cathode powder become more important. Also, the high recovery of valuable lithium becomes important. In order to recycle the used LIBS, non-harmful treatment is inevitable for separator and electrolyte in LIBS. As the energy is necessary for recycling, the price of low electricity costs can perform the recycling of LIBS. Thank you for your attention.
Thank you, sir. Thank you for your presentation. So if anyone have any questions or comments, you can please ask Professor.
Can I ask a question?
Yeah, yes.
Yes.
I'm Kento Saki with Tomorrow Water. Very interesting. I was involved in lithium-ion battery research, so your talk was very interesting. And I understand, we've got to start thinking about recycling material. I do see value in recovering metals you mentioned, things like cobalt, manganese, and nickel. These are transition And also, I can see the value of that. But you did mention recovering cathode material, right? But that may be challenging. After many years of use of battery, cathode, or even anode material go through structural transformation. And the structure is directly related to the performance. So I wonder if you have any data or performance of reused cathode that you recover from one of your recovering process. I would be very interested seeing the data like that.
That is a very important question. Yes, many people after recovering the cathode and regeneration and anode, they had a quality analysis, and also the cost is not yet.
You're saying,
so
recovering cost is outweighs.
So the scientists only researched of the quality and some utilization, but the cost is also important. But the cost considering is not yet. But usually a lot of energy utilization, very nice cathode and anode materials can be reused and recycled. So,
but my question: do you have a data showing
there are a lot of data?
Performance?
Yeah, you can see the. So here I published this channel, so you can see the some reference. Yes.
So if you can send me, I appreciate it. Thank you very much.
Okay.
Thank you very much, Professor Fujita and Professor Ken. So